This video is going to be on how to find derivatives of logarithmic and exponential functions. So first we're going to look at the rules for these. And I'm going to use notation that we have not been super familiar with in class. So first we're going to find d dx of ln x. That just means find the derivative of ln x, and that is 1 over x. d dx of e to the x. I wrote that weird. d dx of e to the x is also e to the x. So the derivative of the original function is just the same thing. d dx of log base a of x is 1 over x ln a. And then the derivative of a to the x is a to the x multiplied by ln a. So those are the four rules that we're going to focus on, and then we want to make sure that we do not forget the chain rule. So we may not always have just a plain old x in there, it might be x squared, and then we have to make sure that we are doing the chain rule and we're taking this, using this as a shortcut, but then multiplying by the derivative of what's underneath afterwards. So the chain rule could show up in any one of these problems. So for all of the examples, the instructions are going to be to find the derivative. So the first problem is going to say y equals ln of x to the third plus 1. So my derivative, I'm going to go ahead and say dy dx equals, and if I look for the shortcut that I'm going to use this one because that says ln, and it would be 1 over whatever you were taking the ln of, and then it's a chain rule, so I have to multiply by the derivative of what was inside. So the outside function is the ln x, so I get 1 over x. The inside function is this stuff, and the derivative of that would be 3x squared. And then of course I want to simplify this if I can. And so the derivative is 3x squared over x to the third plus 1. For my second example, I'm going to say that y equals ln of sine x. So my outside function is ln x, my inside function is sine x. And this time I'm going to use a slightly different notation for my derivative. I'm just going to say y prime. The derivative of ln x would be 1 over x, or in this case the stuff that's on the inside is sine x. And I want to make sure to do the chain rule and multiply by the derivative of sine x. And the derivative of sine is cos x. And so that means that when I simplify this, I get cos x over sine x. And hopefully you're looking at that saying, ah, that's cotangent. So the derivative is actually cotangent x. If we have y equals e to the exponent tan x, then I'm going to look at my rule, my shortcut for e, and I can see that it stays the same. So I'm just going to say, all right, the derivative of this is going to stay exactly the same. However, I need to make sure that I multiply this problem by the derivative of the inside function, which is the tan x, and the derivative of tan x is secant squared x. And there's not really a way to simplify that, so I'm just going to say that right there is my final answer. All right, next we're going to go ahead and do y equals e to the negative 4x times sine of 5x. So again, we're going to use what we know about e to the x. And this time we have a product rule happening. So our first function is e to the negative 4x. Our second function is sine of 5x. So I'm going to use the product rule. And I'm going to say that my derivative is the first times the derivative of the second. And the derivative of sine is cos of 5x. So I did the derivative of sine, now I have to do the chain rule and do the derivative of the inside function, so multiplied by 5, plus the second multiplied by the derivative of the first. And the derivative of e, we keep it exactly the same. And then we do the chain rule. So the derivative of the inside would be the derivative of the exponent, and that's negative 4. And we can go ahead and clean this up just a little bit. I'm going to take my coefficients and move them to the front. So I didn't really do much more math. I just took these things and I moved them to the front because it looks better. For the next example, we're going to say y equals 10 to the x squared. So if we look at the shortcut we're going to use for this one, that would be this shortcut. So we have some base, that's a number a, so it's not a letter, it's not a variable, it's a number. A is a number. And so that means that we're going to keep a to the x, we're going to keep 10 to the x squared, and then we're going to say ln of whatever the number was that was the base. So our derivative here is going to be 10 to the x squared, and then it's ln of 10. And again, we have to multiply by the derivative since we're doing the chain rule. So the derivative of the inside function would be that I'm going to multiply this by 2x. Now I can rearrange this a little bit to make it more proper. We can take the 2x and move it to the front. And then I'm multiplying that by 10 to the x squared, and then ln 10. Feels a little bit more proper. You could have left it the way it was if you wanted. Some of these answers are kind of hard to write because they've got just a lot going on in them. So don't stress if you don't know what order to write it in. All right, and we just have a few more examples. My page is stuck together. All right, so the sixth example that we're going to do, we're going to have y equals 2, and the exponent is going to be secant of 2x. So here again, we're using that same shortcut that we used the last time. So I'm going to say that my derivative is going to be a to the x times ln of the base, so ln 2. And then I have to multiply this by the derivative of the inside function. So the derivative of secant is secant 2x tan 2x. And then I have to multiply that by the derivative of this inside function, and the derivative of 2x is just 2. And we could take this 2 and move it all the way to the front if we wanted to. I'm going to say that this answer is just messy no matter what I do. I'm going to go ahead and leave it like that. You're welcome to move the 2 to the front if you would like. Okay. Next we're going to say y equals log of 2 plus sine x. And so here, the shortcut here, let me look at my notes, for log is we want to know what the base is. So we're going to say this is 1 over whatever we're taking the log of times ln of whatever the base happened to be. So this is the common logarithm. I did not write the base because I didn't need to. Anytime the base is not written, it's really a base of 10. So So I'm going to say that my derivative is 1 over the stuff that we were taking the log of times ln of the base, which is 10. And then we need to do the chain rule, so we're going to multiply this by the derivative of the inside function. And the derivative of sine is cos, and so I'm going to multiply this by cos. And then I can go ahead and simplify that, and the only way to really simplify it is just take the cos and put it on the top. There's no other simplifying that can really be done. I could move the ln 10 to the front of the parentheses, but that's about it, not much more. All right, last problem. Woohoo! So this time we're going to say y equals log base 2 of x squared cos x. So we are doing the same rule that we did last time. So I'm going to say the derivative is going to be 1 over the stuff that I was taking the log of. Actually, hold on. That's silly of me. We are going to be using that rule. We're just going to do it in a second. So, there's a couple ways you could do this problem to make your life a little bit easier, since you can see that these two things are being multiplied together. We want to use our property of logs and kind of split them apart and separate them. And the reason we're going to do that is because this would have been a chain rule that would have had a product rule as part of it. And we're going to avoid that by splitting them apart now. So I'm going to go ahead and rewrite the original problem as log base 2 of x squared plus, because they're being multiplied, log base 2 of cos x, right here. And whenever we expand these, we really should take the exponent of 2 and move it to the front of this problem. However, most students forget to do that. And you can get the same answer even if you forget to do that. So I'm going to go ahead and just kind of leave it like that, assuming that most of us would have forgotten to do that, and kind of show that you're going to get the same answer regardless. So if you would like to move the 2 to the front and kind of complete the problem on your own and check your answer, you are welcome to. I'm going to go ahead and leave it here, since I'm assuming most of us would have forgotten to do it anyway. Okay, so I'm going to think of these two as two separate problems. So for this first one, I'm going to have 1 over the thing that I was taking logs of, so x squared, and then ln 2. And it's a chain rule, so I have to multiply this by the derivative of what was inside, and so that derivative was 2x. And then I'm going to do the same thing over here, so I've got 1 on top. The stuff that I was taking a log of is cos x, and then I have ln 2. And then I'm going to multiply this by the derivative of cos x, which is negative sine x. Okay, so I can simplify this stuff a little bit. I've got an x squared down here and an x up here, and so I can cancel this x up here with one of the x's down there, and then that gives me 2 over x ln 2. And then I have a negative sine over cos, and sine over cos is tangent, and so I'm going to say that's negative tan x divided by ln 2. And I am totally fine with you guys leaving those as two separate fractions like that. However, I would say since this tan is negative, I should just make this a subtraction problem. If you wanted to get a common denominator and put them together, that would be fine as well.